Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Today, we'll be interviewing Chris Badgett, Vice President Technology from Kratos, and Araz Faizi, co-founder and CTO of Kahan Space. We recorded this interview live on the floor of the Satellite Conference in Washington, D.C. The purpose of this discussion is to take a look at space technologies being used for both civil and military purposes. The number of commercial firms intending to or already engaged in space activities are only continuing to grow. Commercial firms could be a force multiplier. Let me start off with a question for Araz. Araz, can you give me a really short synopsis of what Kahan does for space domain awareness?
Well, let's talk about the problem first. Since the dawn of the space age, we have launched a little over 10,000 satellites total. In the next decade, we're planning on launching 10 times that, 100,000 satellites. So let's remember that, 10 times more satellites in one decade. There are estimated 1 million pieces of debris larger than 1 centimeter in diameter orbiting the Earth. Why is that number important? Because traveling at 17,000 miles an hour, a small piece of debris, size of a penny or larger, can destroy a satellite. So that's a threat. At that point, we need to care about it. We're tracking about 30,000 of them. So 30,000 we're tracking. There's about 1 million estimated and in orbit. And also, the conjunctions, which is collision between two objects in orbit, that's changing. We have a lot more operational satellites that are becoming close to each other. So in general, that's been causing a ton of trouble for satellite operators, and they can no longer operate as they used to. So at Kahan Space, we've developed a coordinated autonomous satellite collision avoidance service. We ingest data from various data sources, from government sources, from commercial sources, and we ingest data from owner-operators. And then when we detect a conjunction or a collision that needs operators' attention, we send them notifications. And also we provide them with optimal maneuver plans that are designed with operators' constraints in mind. So, physics-based, non-physics-based. And then we basically automate their collision avoidance efforts.
Chris, Kratos is kind of a big company. What specifically do they do in relation to space domain awareness?
So for Kratos, big company, several different divisions that span anywhere from UAVs to microwave electronics. The one I'm personally familiar with that I work in is from Kratos Space, where we cover a lot of different mission areas, different customers from RF monitoring to Earth observation to comms to space superiority. So we're one of the companies that have a global sensor network around the world looking at RF for RF interference in the global SATCOM belt. So 6 different sites around the world, couple hundred apertures, and just looking for events happening in the geo belt. It could be owner operators, it could be tracking maneuvering objects if they're emitting. So that's something that's a commercial service that we actually offer through our own on-prem infrastructure.
There seems to be a need for transparency in space as dual-use technologies are apparent. For example, just recently, SpaceX turned on Starlink for Ukraine. So the real question is, and people maybe in the audience have the question, is how do you manage this dual usage? Do you just one baseball hat for one, a baseball hat for another? It's kind of tough. Araz, let's start with you. Your company, Kahan Space, provides a cloud-based collision avoidance service. You just mentioned it. So how do you manage your technology for military or commercial applications? How do you juggle that?
Yeah, honestly, it's actually even more complicated than that. So it's not just, hey, we have government and we have commercial. Our services rely on different pieces of data. And then we have algorithms. And then they combine together their services. And then we provide these services to customers. Now, each one of these components, when you look at them, you might have different access level for different commercial operators versus government operators versus international customers. So as you can see, it can become extremely difficult extremely quickly, very complex, right? So for example, you won't be able to, because of restrictions on that come from whatever reason, you may not be able to use this particular data source with that algorithm for that customer. So yeah, it's a kind of the restrictions that we have. It is necessary for obvious reasons. So the way we deal with that is that we have actually defined different access levels for different parts of and different components of our services. And when we decide, okay, so who's going to get access to certain services, we can put it through our kind of logic and make sure that the right person has their access to right data through right algorithms. And again, when you go international, it gets even more complicated because no two countries are created equal when it comes to national security.
Chris, my wife is an assistant principal at a high school, and she does a lot of conflict resolution and conflict management. And you mentioned it earlier, So your company works in the commercial and defense space, but how do you deconflict?
Great question. So similar answers. It all starts with the customer. So depending upon the customer and the type of service they're looking for, that really drives the data that we're collecting. So we not only look at it from the standpoint of where the customer is going, what the data sets that they're looking for, but we also have to back that up all the way through the life cycle of our products and how we're actually building our products. Because in some cases we may have to some algorithms may be specific to the U.S. and we have to consider those things ITAR or EAR. But again, it really just starts with the customer and the particular service that they're looking for. I mentioned a little bit about we can look at RF monitoring from any emitter. That's really just trying to characterize spectrum and seeing what's going on. Maybe there's intentional interference or unintentional interference. Well, that object in space that's emitting we can also do things like geolocation to it, or actually, we'll say spatial location to it through TDOA and FDOA analysis. So we can actually pinpoint where that transmitter, that emitter is in orbit, and actually detect maneuvers and different kinds of change algorithms that you can put on it to give you situational awareness.
As we continued our discussion at the Satellite Show, there seems to be a need for transparency in space as dual-use technologies become prevalent, technologies that can be used for the military or the commercial. For example, SpaceX turning on Starlink for Ukraine. How do you manage dual use? Araz, let's start with you. Your company, Kahan Space, provides a cloud-based collision avoidance system. How do you manage your technology for military or commercial applications? Is there a way?
Yeah, so the term SDA, by the way, it gets used a lot. So we have a Space Data Association, and so SDA, what Space Domain Awareness, I guess, kind of originated in the government and military, because we need to understand what every asset is doing, what the intention is, what the declared intention is, what the actual intention is, how it's different from what we're observing. So we need to be able to identify imminent threats or potential threats. So the awareness from that perspective makes a lot of sense, and obviously, it is as a necessity. But from a commercial customer base point of view, not basically our commercial customers say, I don't think necessarily a space domain awareness is relevant to space operators. It's mostly because what they really care about is traffic management. They really want to know what to do when there's an upcoming conjunction. They want to know in the trajectory that they have, if there's any threats in front of them, or if they're launching a new mission, what orbital regime they want to in, because they want to understand what the current situation in that. So, in our opinion, as STM, space traffic management, applies a bit more to commercial customers of our services. But for us, on the SDA side, obviously we need to make sure that we have a clear understanding of the intents. And especially with the way things are going, if imagine having 100,000 satellites in low Earth orbit, just imagine trying to figure out what is an anomaly, right? It's going to be extremely difficult, and we have some projects that we're working with the U.S. government to assist in that world.
Chris, I got a question for you. If you read the current literature, there's a phrase called an existential threat. So one man's traffic management is another man's existential threat, isn't it? I mean, it all depends how we define this, right, Chris?
No, absolutely. So that existential threat, it's really about if you're going to proliferate and take advantage of the different orbital regimes, then you have to understand some of those consequences from orbit phenomenology, a kinematics situation. So the problem not only is kinematics in a spatial sense, now you overlay that with emissions and RF interference, because all those things could be emitting, could be interfering with other gateways on the ground, could be interfering with co-orbital objects, could be interfering with things above them, say in MEO or GEO. So the problem is not only an existential threat, it becomes an exponential existential threat, because it's really now you're trying to solve these problems across lots of different domains, not only MEO, GEO, LEO, but in the EW spectral space as well.
Raz, well, here we are in Washington, D.C. at the Washington Convention Center, all kinds of people. There's government agencies near here. I've been in many of them, talked to a lot of the CIOs. So from your perspective, what does the SDA need from governments or other entities in town here to maybe achieve its full potential? What does it need from governments for space domain awareness to reach its full potential?
That's a good question. So my answer would have been different, maybe 6 months ago. Today is a bit different. So, so from a national security perspective, we've always had to keep track of objects in orbit. The systems that we developed, the Space Surveillance Network was developed a long time ago to prevent, to detect and to take ICBMs and other threats that are coming our way. And as a byproduct of that, we're tracking all these objects. One kind of parallel that I see here is, traffic management for air travel. There are radars that are owned and operated by government, and the data is collected, and this data is provided to all operators because it's it's best interest of everybody. It's best interest of commercial industry, best interest of national security and the government. Now, we strongly believe that the data plays an extremely important role in deciding how fast we can innovate in space. There are government data sources that are paid by taxpayers, developed by taxpayers, and built and operated by them, and they should be provided to everyone as much as possible to keep spaceflight safer. However, there are commercial providers that also have invested, and then they generate a lot of data that's very useful. We believe that commercial industry and also government can work hand in hand. There's a great opportunity for private-public collaboration in this area, where we ingest data, we bring all the services, and we provide it to everyone. For example, some different nations have taken different approaches. Europe has a kind of controversial approach where they've kind of started providing certain services where it's making the world a bit less competitive for European companies, and I know a lot of European companies are not very happy about that. But we really think what U.S. government has done so far, and the efforts that are in progress today, both in Department of Commerce, NOAA, and DoD, are going to help us, improve the safety of flight for all satellite operators.
Raz, I'm going to state the obvious here. I'm an old guy. You're a young guy. When I was a young man, satellites were the size of like refrigerators. Now they're the size of cubesats, maybe ice cubes in the refrigerators, kind of small. And so it's one thing to track a refrigerator, but another thing to track a CubeSat. So how can you correctly identify different CubeSats and they're launched simultaneously?
It's a great question, right? So I remember talking to a company that were talking about deploying thousands of picosats, where they're even smaller than what we are capable of tracking today, and that's obvious. That's very dangerous. And so there are different ways. There are different companies that have different solutions that make it easy. For example, the tags or reflective surfaces that make it easier for ground trackers to track these objects. Well, as a company, we're not involved in that process. So we use the data. We work on algorithms, and we continue to work on algorithms that help with what's called IOD, initial orbit determination, identifying the small objects that look alike and they come out of the dispenser at the same time. From a policy perspective, I think that we need to make sure that we are good neighbors to each other, right? So if you're operators, even though there are no guidance, even if there's no regulation that is forcing you to identify yourself or cooperate with your neighbors, I think as an industry we need to collaborate with each other, tell everybody where we are. Now GPS is very, very feasible even for one USAT. So and when we talk about transparency, we believe that there needs to be transparency in terms of sharing some basic data that's already kind of available out there. So I don't know if that directly answers your question, but yeah, so that's our vision that we need more transparency. We need more people to share their data.
Yeah, just to add on to that, in the situations where it's cubesats or any vehicle in particular, different phenomenologies that can be applied from a space domain awareness. You can use optical, radar, or we typically are the RF experts there. So we'll take the signals that are already coming off the satellite and be able to use that to differentiate from a location perspective. So to address some of the possible cross-tagging in small volumes for CubeSats, you can use some of those signals to your advantage and actually do TDOA, FDOA analysis, so you can resolve those objects in specifically in a CubeSat, kind of a hard problem there.
Got a football question for you, Chris. About a month ago, there's a Super Bowl, and it's one thing to hit someone with a football when they're stationary, a whole lot different when they're running and someone's chasing after them, so a moving target. So how do you maintain RF situational awareness with moving emitters and still ensure comms? I mean, that's the moving target, isn't it?
Yeah, no, that's a fun problem. So where space has changed over time, and as vehicles have, we've proliferated LEO. The physics have changed a little bit more, right? GEOs objects or geosynchronous tend not to move too much. MEOs, and then we're getting to LEOs. You have to take those things into account. You experience a lot more Doppler shift. You have to have better pointing, better tracking antennas. But there's really a lot of interesting things that you can do from understanding and tracking those transmitters and those as unique identifiers, and then track those things and keep custody of them in a catalog that can be presented, so that way you actually are keeping track of those moving objects in LEO. So it's a little bit harder problem, but it's not an insurmountable problem.
Well, Roz, I got another Washington, D.C. question right in the thick of things here. We have a lot of intelligence agencies around town. They get attacked a whole lot. And some share information on cyber attacks, and some are very wary of sharing information about cyber attacks for a lot of different reasons, all kinds of ethical and moral questions here. So let's take this to the world of satellites here. So how do you share data internationally and across organizations? I mean, how much is the good stuff and how much is fair to share?
Yeah, I'm just going to go back to my answer to one of the first questions where, I was talking about how different types of data that we have access to and we receive have different access permissions or levels for different consumers. So we always abide by those access permissions. We track them properly, we tag them properly, and every time a data is provided to a certain customer, we make sure that it is it's checking all the boxes. One example I'll give you is that it doesn't matter where you are from. You can always go to spacetrack.org, create an account, and get access to TLE catalog. So it's public information. So we can use TLE's data for anybody, pretty much. Whereas we have access to more proprietary data or protected data where we can only use it in certain cases for certain projects. So it is very, very important for any service provider or any company to pay attention and make sure that the right data is always provided to the right people.
Question for Chris here. I guess there's room for a commercial-based aggregator of space domain awareness information. Do you have any examples of this today, or is it just limited to the intelligence community or commercial community?
No, actually, you actually brought it up from an intelligence community. There are some examples where NGA continues to buy commercial imagery data. So that's a great model that you can actually apply to from an SDA perspective. Lots of commercial operators are out there that you can actually pull in from their sensors and from their infrastructure into a larger aggregator. The Unified Data Library is another good example of where people are actually putting their data depending upon the sensor type. So a couple different examples, but yeah, I think there's a great model, and Space Force is actually going through from a commercial engagement strategy and actually building an office around some of these opportunities for aggregation.
Let's talk about space sustainability. Azaz, I have a couple daughters that are very interested in sustainability because they're going to be around a few more years than I am. And so people talk about space sustainability. What does that mean to you, space sustainability?
So I'll ask a question. Is space the same today as 60 years ago? It's not, right? is it going to be the same in 60 years from now? And it's not. Research came out, I think it was UT Austin, it was a research came out at UT Austin, and then they estimated that 95% of the carrying capacity of lower Earth orbit is already taken up by space junk. 95%, right? And that was before the Russian ASAT test, so you can only imagine. So the way we've operated so far in space hasn't been really, I guess, sustainable. We've created a lot of debris, intentionally, unintentionally, and that has made it a lot harder for operators that are coming online today to operate. And if we continue as we have, operate as we've in the past, hopefully we're not. For most part, we're not doing most of the things that we were doing, years ago, we're not doing anymore. But if you continue down the same path, lower Earth orbit will be unusable. And let's remember, lower Earth orbit is not just for satellite operators. If you want to go to moon, you gotta pass through it. If you want to go to, perform any kind of interplanetary mission, you have to pass through this cloud of debris. And it can get to a point where it makes it very, very difficult for anybody to do any kind of innovation in space. So in my opinion, sustainability in space is that we should consider every next generations and next companies that are coming out and they want to innovate in space and make sure that they have all the resources that they need that were provided to us is also provided to them. So if you can make it better in the short term, at least let's not make it worse.
Chris, from your perspective, so what do you think of how would you define space sustainability?
So very similar from an object and traffic management standpoint, but even to build on that, it becomes sustainable from an emission standpoint. I mean, FCC understands this. Spectrum contention is not going to go away. All we can really do at this point is, as we continue to grow, we're going to probably move up into newer bands as other things have contention. We maybe get smarter from a dynamic spectral awareness standpoint, be able to reuse spectrum in different locations, but all of that implies a much larger management scheme that's actually dynamic instead of where it's actually fixed and you actually have a license to operate in this kind of orbit regime. We may get there are probably techniques that we could to use, but that would actually involve a much larger scale solution that crosses organizations and governments on how to be dynamic and how to reuse spectrum.
Raz, I want to go back to my wife in the high school assistant principal. You get a bunch of teenagers together, there's all kinds of unexpected events. I mean, car crashes and things happen and fist fights and all kinds of things. And so part of space sustainability must be expecting the unexpected. There's going to be events that are going to happen, and they have to be controlled. So this is going to have to mean cooperation between civilian and military organizations, and you may sit in the seat here coordinating on it. Is that right?
Yeah, absolutely. So, we deal with it today. We deal with it on a daily basis. You look at all the, when a mission is launching, you usually have a discussed or mentioned intention of that mission. We see it on a daily basis that a lot of times the data they collect from a physics perspective on these assets, whether it's the capabilities they have, or their mass, or the orbit that they're going to, or the RF activity that they have, it doesn't really work. It doesn't really jive with what the mentioned intention of that asset has been. So that's one example of where in space there are a lot of times that we are surprised. Well, maybe not surprised, but we find cases where it's unexpected. The behavior is unexpected. The activities is unexpected, and the list goes on. There are many of them, right? So as an industry, we need to make sure that we are, first of all, transparent as much as we can, and obviously for obvious reasons, you can't always be very transparent in some cases, but at least to make sure that we have a safe orbital environment and safe environment to operate in, we have to build and develop technologies where we can identify the unexpected behavior and deal with it in a timely manner. And that's one of the reasons that we keep talking about autonomy, because when you have human in the loop, you have error, you have a human error, you have delays, and at orbital speeds, at the pace that things happen in space. And we're getting to a place where human can no longer be in the loop in many, many cases, whether it's responding to an unexpected event, or detecting something unexpected. You can't really rely on human eyes to do it anymore. The volume is so high, that the speed is so fast. So we believe that autonomy is the only way we will be able to operate efficiently and safely in orbit going forward, and that includes detecting unexpected.
Araz and Chris, we've looked at both sides of space domain awareness and a lot of insights here. I'd like to thank you, gentlemen, for opening up the eyes of our listeners to the possibilities of commercial world helping improve space domain awareness. I'd like to thank our guests, Chris Badgett, Vice President Technology at Kratos, and Araz Faizi, Co-founder and CTO at Kahan.
Thank you for having me.
Thank you.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.